Greetings everyone. In this video we are going to look at how to configure our microcontroller, the ATMega16A, so that it is going to use an external 8 MHz crystal. So open the data sheet and then go to this section over here, system clock and clock options. So you will have a block diagram detailing the clock distribution in our ATMega16 microcontroller. So this is the portion we are interested in, the blocks which are connected to this clock multiplexer. This clock multiplexer is going to choose from a variety of clock options. Let's see what options we have. We can use an external RC oscillator, an external clock, that is you can give a external square wave. You can use a crystal oscillator, a low frequency crystal oscillator, and a calibrated RC oscillator. This low frequency crystal oscillator is approximately this 32 kilohertz crystal. You have the option of using that as well, or you can use a high frequency crystal in the megahertz side. That is what you are going to do. This is the option we are interested in. We want to use a external high frequency crystal oscillator. But the device, when you buy a brand new ATMega16A microcontroller, it comes configured to use the calibrated RC oscillator. We are going to change that and make the microcontroller use the external crystal oscillator that we are going to connect. So let's scroll down and have a look at this table over here. This table lists the clock sources, right? We looked at this multiplexer which can choose many different clock options. So this is the table which lists all this in detail. So we are interested in this one, external crystal, not the ceramic resonator. We are interested in external crystal, not the low frequency crystal, but the high frequency external crystal. So for that we need to look at these bits, CKSCL. These bits, they are called as fuse bits, which we will look at shortly. They are actually the low fuse bits. We look at what they are in detail. But now the only thing you need to understand is, if you want to use a external crystal, then your CKSCL, this clock selection bits, it's actually 4 bits, should be 1111, binary value 1111. So what we'll do is, we'll just note it down. So for external high frequency crystal, so what we should do, CKSCL bits from 3 to 0, 4 bits should be equal to 1111, binary value 1111. And then we will scroll down a little bit and have a look at this default clock source. This is very important information. So when you buy a brand new IC, a brand new device, it is shipped with CKSCL equal to 0001. So what is 0001 CKSCL? Look at this 0001. It stands for calibrated internal RC oscillator. So when you buy a brand new IC, it comes with CKSCL 320 as 0001. And SUT bits stand for startup time. You can choose the startup time with these bits. We will look at it shortly. So SUT bits are going to be 10. What this will do is, these bits will choose the internal 1 megahertz RC oscillator with longest startup time. So when you buy a brand new device, it will work with 1 megahertz internal RC oscillator, but we don't want to use that. We want to use a crystal oscillator. We have connected a crystal oscillator between the XTAL1 and XTAL2 pins. So we will scroll down a little bit. See, this is the pin connection. This is the crystal which is connected between the XTAL1 and XTAL2 pins. And then you need to use bypass capacitors over here, C1 and C2. The bypass capacitor values also will be specified over here. See, if you want CKACL 3 to 1 bits as 111, you can choose a frequency range between 3 to 8 megahertz, and the bypass capacitors that you are going to use, C1 C2 capacitors, they can have any value from 12 to 22 PF picofarads. Now this board comes with a 22 PF capacitors. And there is one more thing we have to note here. We have already noted down the value of CKACL 3 to 0. Now there is one more option over here, CKOPT. This also will be present in the fuse bytes. Shortly we will see where it is, whether it is in the high fuse byte or low fuse byte, and we will program it accordingly. Okay, so for using the 3 to 8 megahertz frequency range crystal and 22 PF capacitor, CKOPT should be 1 and CKACL bits 3 to 1 should be 111. We have already noted down the values of CKACL bits. Now we are going to note down the value of CKOPT. So CKOPT bit value should be 1. Okay, then we look at the SUT bit startup time. Okay, this table over here, these are for ceramic resonators. We are not using ceramic resonator. We are going to be using crystal. So this table is for crystal. So if you make CKACL 0 bit as 1, which we have already done, see, CKACL 3 down to 0, the 0th bit is 1. So if CKACL 0th bit is 1 and SUT is 01, you can use a crystal oscillator with BOD enabled, brownout detection enabled. If it is 10, you can use crystal oscillator with fast rising power. After reset, you will have a delay of 4.1 millisecond. If SUT bits, SUT 10 bits are 11, you can use the crystal oscillator with slowly rising power, and then the delay will be 65 millisecond. So I am going to use this option. SUT 10, I want it to be 11. So I will note that as well. So I want SUT 10 to be 11. Okay, now we have noted down all these fuse bits. We will take a look at the fuses in our AVR microcontroller. For that, you have to scroll down and look at memory programming. Click here and click here, fuse bits. See, the ATMega16A has 2 fuse bytes. You have the high fuse byte and then you have the low fuse byte, right? So I have been looking at certain bits, right? SUT 0, SUT 1, CKACL, and then CKOPT over here, right? So this is what we are going to program. We have to program the high fuse byte and the low fuse byte, either one or both. Okay, So now let's examine the values which we have noted down. In the high fuse byte, we are going to leave everything else as default value. We are going to focus on CKOPT. So what value do we want? The CKOPT value we want is 1. We will see what is the default value. See, default value is 1. So while shipping itself, this device comes with the CKOPT value of 1. We also need a CKOPT value of 1. So we are not going to touch the high fuse byte. What we are going to do is we are going to only program the low fuse byte. If we scroll down a little bit, see the SUT bits, startup time bits. You have SUT1, SUT0. So what I want to do, I want SUT1 and 0 to be 1 1, and then here you have the CKACL bits, right? We want the CKACL bits to be 1 1 1 1. Okay, let's look at the default values. So CKACL 3 2 1, these are all zeros, but we don't want this to be zeros. We want all this to be 1 1 1 1. And SUT1 SUT0, it is 1 0, but the value that we want is 1 1. So we are going to leave these as such, BOD level, BODEN. We are going to ignore these two. We will keep it at the default value 1 1. SUT1 and 0 we are going to make 1 1, and CKACL 3 to 0 we are going to make all ones. So what is the byte we have to write into the low fuse byte, that we will see. So you have bit number 7, bit number 6, bit number 5, 4, 3, 2, 1 and 0. Okay, so bit number 7 and 6 we are going to leave it as 1 1 in the unprogrammed state. Bit number 5 and 4, they are the SUT1 and SUT0, which you want to make as 1 1. So I will write 1 1. Bit number 3 2 1 0, they are the CKACL bits 3 down to 0. I want them all to be 1. So 1 1 1 1. So this is a binary value, 8 ones. If you convert it to hexadecimal, it will be 0xFF. F stands for 1111. So the upper nibble is 1111, which is F. Lower nibble is 1111, which is F. So this is the value which you are going to write into the low fuse byte. So this is the value you are going to write into the low fuse byte, 0xFF. So if you do this, your microcontroller will be configured to use the external 8 MHz crystal. Okay, so for writing this value into the microcontroller, we are going to be using the USB ASP programmer, this one over here. We are going to connect this to this microcontroller board, and then we are going to program it using one software called the AVR Dude. So in the next video I will show you where you can get this software and where you can look at the documentation for this software. We are going to do this programming from the command line only. So we are going to see what are the options, various options, and how to program the fuse bytes in the next video. And one important warning, when programming fuse bytes, you can play with this if you want, but you have to be very careful. If you are not careful and you write the wrong values into the low or high fuse bytes, you will end up with a bricked device. You will end up with what? Bricked device. Bricked device means you cannot use this device for doing anything else. If you screw up this fuse bytes, the only thing you can do is use it as a brick somewhere. You cannot do anything else with this. So important warning, whenever you are playing with the fuse bytes, be very careful. Look at the data sheet, find out all the fuse bytes that you are going to program, what values you are going to write, and then while programming be very careful to program the right fuse byte. Okay, right. So I will see you in the next video.